Hello, this is Jeff Butler, and I'm a Volocity Application Specialist with Quorum Technologies. Today we'll be showing you a brief overview of the Volocity software package, moving from capture to analysis and then to presentation. This can be accomplished best by moving through each of the four Volocity modules: acquisition, restoration or deconvolution, quantitation, and visualization. These four modules are coordinated through the Volocity library. This library is essentially a user-friendly database that allows you to organize, sort, and review your raw, processed, and quantified images, along with results of that quantitation. With Volocity, you can have as many libraries as you like, with as many images in each as you like. Each library can contain images from a set of experiments, or as a project, as you see here, or whatever organization makes sense to you. To open the library, simply double-click on the library file and Volocity launches. Once Volocity is open, you will know that the library has an internal structure to assist you in organizing your data. Clicking on any folder will show you the contents of that folder. Alternatively, you can click on the arrowhead beside the folder, revealing its contents in a list view. You will note that either view shows image thumbnails for ease of navigation. Frequently, it may be convenient to change the item name. Click once on an item name to select the item, then click again to open the text in an editable field to change the name. New folders can be created through the Actions menu or through a keyboard shortcut. The new folder shows up at the bottom of the library, and moving items to that folder is a simple click and drag. If you transfer the library between computers or export a folder as a library clipping, this architecture is maintained. One of the key aspects of Volocity is its seamless flow between the live acquisition mode and the library containing your captured images. Simply click on the image of interest in the library below the video preview. The thumbnail icon makes this navigation intuitive, and it is simple to review more complex acquisitions, be they stacks or time courses. A simple click on the video preview icon returns you to your live preview. This video preview is, by default, active, so that you can quickly review captured images and then choose an appropriate field for your next acquisition. One of the most convenient aspects of Volocity is the capture of a single frame, which can be done by simply tapping the spacebar, and the image in the video is added to the bottom of the library. While this most basic aspect of the Volocity acquisition is useful, most acquisitions will be more complex, so we will review this process as well as the workflow through to image processing, analysis, and presentation. Accordingly, we will begin in the Volocity acquisition view. Here you can see your live image, which occupies the center window. Down the right-hand side, you can see the hardware that Volocity is currently controlling. Volocity supports a wide range of cameras, microscopes, and associated hardware. The controls are organized according to the device to which they belong. In this simple setup, this would be a microscope and camera. If you have a large number of devices, you can minimize their display by clicking the turn-down arrow, as we've done here. While the program can control individual components, you will generally want to have preset configurations of your hardware in the combinations necessary to image each fluorochrome as well as your transmitted light paths. You can record the positions or settings of as many devices or as few as you require. Once the light paths have been defined, you can set up more complex acquisitions through the Acquisition Setup button. This option is also available through a drop-down menu, but it is generally more convenient to simply double-click on the icon in the interface. As you can see in the Acquisition Setup view, you can set up experiments with control of the various fluorescent and transmitted light paths, along with your focus drive for simple 3D acquisition. You can then add a time course and multiple XY points. We also have options for image stitching and autofocus. More advanced functionalities are also available. Another very useful feature of Volocity is its ability to use a motorized XY stage to generate an overview of your working area, be it in a slide or a dish. To do this, you simply move to the XY stage view. This view shows you a map of your stage with each square representing a field of view at your current magnification. You can then draw an ROI and the stage will scan the selected area. You will note that this scan is a simple mosaic for reference rather than a fully stitched image, which, as I mentioned earlier, is an option in the Volocity acquisition menu. This can be done at a low magnification, and the resulting map can be utilized when working with high magnification objectives. Once the scan is complete, you can move around the scanned preview simply by double-clicking at any point in the stage preview as shown here. Once an image has been acquired, it is often useful to improve the image quality through deconvolution. The Volocity Restoration module is a powerful tool to remove out-of-focus haze and improve contrast. With the implementation of microvolution, users can now deconvolve images that used to take tens of minutes in only a few seconds. This ability makes deconvolution of entire time courses practical and batch processing much more convenient. It also becomes practical to deconvolve an image immediately after acquisition to determine if further acquisitions are required. This example running at actual speed shows the deconvolution of an image that is 528 by 608 pixels with 71 slices. Deconvolution is often critical in situations involving the analysis of tightly clustered objects where automatic detection would otherwise prove difficult. Volocity quantitation provides comprehensive options to analyze both structure and function in 3D and 4D image datasets. Objects can be identified, measured, and tracked in all 4 dimensions. Moreover, these objects and tracks can be viewed as overlays to your image data, making it ideal to demonstrate relationships between structure and function over time. For more complex systems, Volocity also includes options for ratio, fret, and frap. Velocity quantitation can be accessed by simply clicking the Measurements tab above the image. This will reveal a new window view with 4 key panes. The Image pane, which provides dynamic feedback on the objects identified. The Protocol Tasks pane, which provides you with a wide variety of tools to identify objects of interest. The Protocol pane, where you will build your quantitation protocol. And the Measurements pane, where the resulting measurements can be shown as either a spreadsheet or a histogram. In this protocol, there are a number of steps, but in all protocols, the first step is defined by intensity. Volocity has an automatic thresholding algorithm that utilizes Otsu's method to separate signal from background. An offset from the calculated threshold can be applied to further refine the objects identified. The threshold is recalculated for each time point, so automatic thresholding is ideally suited to multi-time point datasets or for batch processing. This can be accessed simply by clicking on the cog here, as well as the automatic mode, simple intensity, standard deviation of intensity, and percent of intensity are also available as thresholding methods within this task. Additional tasks to optimize object identification also include functions such as separating touching objects and excluding objects, either by size or other criteria. These functions can be added to your protocol by simply dragging them from the Tasks pane to the Protocol pane. Once you have identified the population or populations that are of interest, you can record these data values in a measurement item which is stored in the library. The link between the measurement item data and the image is very useful when you wish to review the objects that you've identified and quantified within the image. Finally, Volocity offers a visualization module to create a high-resolution 3D rendering of your data, which is fully interactive, allowing you to explore your object in 3D. This capability can be accessed through the visualization mode at the top left of the screen. For most applications, you will choose the 3D opacity view. Here you can zoom, pan to center your image, and perform a freehand rotation. You can also create movies of these actions, thus allowing you to share this 3D perspective with your colleagues as you rotate, zoom, and fly through the rendered object. Even more critically, it allows you to combine your quantitative analysis with 3D rendering to get a better idea of what's happening in a 3D space, which is often more relevant to a biological sample than a 2D perspective. In this example, you can see a 3D rendering with 2 different populations, nuclei and vacuoles. You can overlay this rendering with the objects you've identified and quantified. And finally, Volocity can help you illustrate the relationship between these 2 populations. Nor is this capability limited to simple 3D data. Volocity can also track objects in 3D over time. Thank you for watching, and we look forward to hearing about how Volocity might be able to help you with your research.